I would guess it's anywhere from 4 to 6 inches, depends on where you're at. So as I mentioned, this is the Mendenhall Glacier, and this valley was originally carved out during the Great Ice Age, but then when that glacial time period ended and eventually the Little Ice Age started, this glacier had its farthest advance in 1760, and it's been mostly receding ever since, and it's overflowing snow and ice pulled down by gravity from the Juneau ice field above. And water, whether it's a liquid or a solid, absorbs the long wavelengths of light. Where the ice is extremely dense, it forms a crystalline structure and acts like a prism. So that's why we see it looking blue, because the shortwave light, I should say the reds and the yellows, are able to pass through the long wave light, and they're absorbed, and the shortwave light, the blue, is allowed to pass through and acts refracts back at us. That's why we see the bluest parts at the bottom of the icebergs, and where on the glacier it's mostly white, that's where it's been exposed to sunlight, so the ice has been allowed to expand, and the gas molecules inside of it, like oxygen, have been allowed to expand, so therefore all of the visible light spectrum is absorbed, and we see it as white because it's no longer a dense crystalline structure that is transparent. At that point it becomes opaque. And those are people at the base of the Nugget waterfalls. That waterfalls is about 250 feet high, and that comes from the Nugget Creek, which flows off the Nugget Glacier, which is a glacier up here. And yeah, so this is Mendenhall Lake. Its outflow is the Mendenhall River off to our left, and then there is what's called Steep Creek over to our right, over by this cool looking little iceberg over there, and that's where the salmon come up and spawn. So they come up the river, they flow through the lake, and then they go over to the creek. They come up there and they spawn once and die. In this time of year, we can kayak out to the glacier in about 45 minutes. It takes me about 30 minutes to come back, often if there is a katabatic wind, which is a glacial wind. And then off to the left side of the glacier, you can't see it from here, but it's fairly flat, and you can hike on there without any special equipment. On the rest of the glacier, crampons and ice climbing gear would be a good idea. I actually go inside of the ice caves. There's newly formed ice caves almost every week. It changes. The glacier is constantly flowing, so it's pulling down about a half an inch up to 2 inches half an inch up to a foot every single day. So it's evolving, it's changing, it's literally flowing like a river. And what's happening currently is this glacier is receding very rapidly, and it's partially due to its location on this lake. So you may not have ever heard this on media before, but it's an important piece of the puzzle. So there's multiple factors, in my opinion, why glaciers are receding. And one of the reasons why this glacier is receding is its location on the lake. So my grandparents were here in 1957, and my grandmother's 93 years old. So they actually viewed the glacier behind us. The glacier was behind us at that time. And at that time, they could not see this beautiful Mendenhall Lake. There was a little part of it over to the left, but it's out of our sight and was out of their sight in 1957. So what's happened is, after 1946, the Mendenhall Glacier began to retreat in this area, and it allowed this lake to be filled with water from rain, from snow melt, from glacial melt, from glacier melt from other glaciers, and fill this basin up full of water. Now we call it the Mendenhall Lake. And what happens is, every day when the pull of gravity pulls that glacier down and it hits the surface of this lake, it creates an opposite force, so to speak. So that pull is down, and now it hits this lake. And water really doesn't want to be displaced. You know, those molecules fight a little bit before they're displaced. So it creates somewhat of an opposite effect. And it's somewhat of a resistance. So that resistance every day when the glacier is pulling down creates a weak point in the face of the glacier known as the terminus. And we call those calving icebergs. And it can be, depends on, you know, what type of water body. Anywhere from 70% to 90% of the iceberg is below the water surface. So that's why the Titanic sank, because they couldn't conceptualize how big that iceberg was, for example. So the lake is over 250 feet deep in places, and what that creates is these giant icebergs that flow off the glacier sometimes every day in the summertime, and eventually, if they're not trapped by the lake bottom, then they'll flow off and melt away in roughly a week or less time. So there's actually a couple more icebergs than there were yesterday, so it looks even quite different than it did yesterday. So it literally changes, and so that's one of the factors that's causing this glacier retreat, but there's other factors as well. We're seeing a warming trend in Alaska of roughly 1 to 2 degrees per year, and that's causing this glacier to be less dense. It's causing it to be less wide and less thick because of that warming trend. And a lot of people, when they visit this place, they want to know, okay, is it a global warming, so to speak? Well, I'm not a glaciologist, I'm not a climatologist. All I know is the facts and what I see with my own eyes. And I see this glacier retreating. It's retreated about 500 feet in the last year or so. So that's an average, a high average for the last couple of years. Some years it's less. There are glaciers on this ice field that are advancing, and it's considered an advancing glacier if it's advancing faster than it's retreating. Because of course every glacier is being pulled down by gravity, so sometimes a little hard to conceptualize what does that mean, advancing, retreating. But basically, retreating glacier is retreating faster than it's advancing down the valley. So yeah, I also think that we could all do a better job of reducing our carbon footprint. I do think that man does have an impact on the environment. To what extent is man-made and what extent is a natural, cyclical warming event of the Little Ice Age? I have no idea. I'm not a scientist. But that's for you to decide. So you come here and you see these things for your own self, and then you go home and you make your own opinions about what you see. But I know it's a beautiful place. We're very fortunate to call this place home. It's our playground. I actually get a little emotional sometimes when I see it on such a pretty day like today. Now, if you came on a cloudy day, it would look a lot more blue. But in my opinion, this is my favorite time to see the glacier because it's so calm. You can see the reflection of the glacier in the lake. And it's very rare to see that. So to me, it's a beautiful day. Another thing that I want to point out is you can actually see glacial succession or mash with your own eyes. Because if you look near the glacier, to the right especially, you notice there's nothing growing on that rock. Because see, that rock was covered. I moved here in 2012. And that big rock hump that you see, that's about where the glacier was when I moved here. It's changed that much since then. And then if you look back farther, you'll see more green. And eventually you can see alder. And then if you look up higher and back farther, you can see those pointy Christmas trees, spruce trees. And then you can't really see because the hemlock are still in the shadows, but the hemlock would be farther back in the succession. This peninsula here to the left is a rookery for glaucous-winged gulls. And over here to the right, in this flat spot, is a rookery for Arctic terns. So as glaciers retreat, they do provide a new habitat and new forests to grow, salmon streams to develop, lakes to change and develop. So I mean, there is sometimes a silver lining as far as we do see things growing and inhabiting an area that once was a glacier eventually. It just takes a little while for the forest succession to start. But I also want to point out this peninsula to the left was the face of the glacier in 1989, and it went all the way over to Nugget Waterfalls. So it's a little hard to see, but we're probably about 2 miles away from the face of it. And so that's a long ways. That's a long ways out there that glacier has retreated since 1989. And it's 13.5 miles, so we're only seeing a little fraction of it, so it's hard to say if it'll still be here for our great-grandchildren to see someday. Probably. Will it be less of a spectacle? Probably. Will it be possibly out of sight of the visitor center, which you can't really make out, but it's right over there. That's where most people come to see the glacier. So anyways, those are a few things I wanted to point out. Do you guys have any questions?